Hello my dear students, welcome back to NEET World. So this is our session 2 on structure of atom. Okay, and this session is highly helpful if you are preparing for NEET, JEE and EAPCET exams. Okay, and in the previous session also I have covered almost 15 to 20 questions. All of them are PYQs of NEET, JEE and EAPCET exams only. Okay, so in this session also I have brought few more questions from JEE and NEET exams. Whatever the PYQs we have got in those exams. Okay, and this whatever I have selected, these are really important for your exam point of view. Just look at this. I will show you one by one. You just follow them. What are the questions I have brought here? See, the first question is from quantum numbers. Okay, the next question is from Bohr's atomic model, Bohr's atomic model as well as de Broglie wavelength equation. So it's very easy. First of all, let's discuss this quantum numbers first. It's a very simple and easy question. See what they are saying. They have given 4 quantum numbers in each option, and they are asking us what is the energy order of this electron. So what is the energy order of these given options? Okay, based on there, if electron is present in first orbit and electron present in like that. See, they have mentioned quantum number here 4 and azimuthal quantum number, angular quantum number 2, and here 3, here 2. So like that we have different numbers, and they are asking us to arrange them based on the energy order. See, it's very simple. Whenever a single electron system is given, you need to check only for n value, but if multi electron systems are there, n plus l value you need to consider. Okay, right. So based on this, you tell me now what is the answer you will get. So just add them. Here you got 5, here also you got 5, here you got 6, 5 and 5 here it is 4. Okay, so where do we have bigger number? Here 6 now, n plus l value is highest for 1, so it is highest energy. And after this, these are both of them are same numbers. Here n value, greater is the energy for this one. Okay, if n plus l values are same, then consider higher the n value, higher is the energy. Both n plus l value same here, so but n value is greater here. So it means 3, next 2 and least is 4, that's it. So this is what your final answer. So 1, 3, 2, 4, so option B is a perfect answer for the question. Okay, right. The next one here, tell me what will be your answer for this. The de Broglie's wavelength for an electron in the 4th orbit is, okay, so in terms of pi into a naught, so where a naught is Bohr's radius. See, it's very simple. First of all, tell me what is the de Broglie's wavelength equation. Lambda equals to h by mv right now. So now here they are connecting it to Bohr's atomic model. So how can we make it? See, we have mvr equals to, like quantization condition, mvr equals to nh by 2 pi, right? So from this I can write mv is equals to nh by 2 pi r right now. So this is what we can write. So from here wherever I have this mv, okay, so there I can place this thing now. So lambda is equals to, I have h by mv means nh by 2 pi r, so by 2 pi r. So that means I can write here, see they are asking about what is this, de Broglie's wavelength of an electron in the 4th orbit. So you can write here 2 pi r, that's it. Okay, in the denominator I have written here. Okay, so from here you can remove this 2h. Okay, and next one here, lambda is equals to 2 pi as it is, because pi they have mentioned, and r means what? Radius of an nth orbit, radius of an nth orbit. What is the formula for radius of an nth orbit? 0.529, okay, n square by z, angstrom units. Right now like this we are taking. See, they are saying a naught is a Bohr's, it means first like first orbit radius is how much? R1 if I want to take, so that will becomes this much. So that value is how much? This constant they have taken it as a naught into n square by z. This is a formula we can use here. So I am writing 2 pi in by n, in the place of r I can write that a naught into n square by z. Okay, they are talking about hydrogen atom only, so z value, atomic number will be 1. So this is 1 here. Okay, this is 1. Okay, and the next one is they are saying fourth orbit now. So fourth orbit means what happens to n square? So 4 square 16 now. So here you can write lambda is equals to 2 pi a naught by 4, n is 4 here, and here n square, that is 4 square 16 here, that so you can write it as 4 only. So what is the final answer you are going to get? So lambda is equals to 8 pi a naught will be your final answer. So what is the number we need to fill here? The de Broglie wavelength of an electron in the fourth orbit. Here simply you can write 8 pi a naught. Okay, so your answer should be 8 here. Okay, I hope each and every step that I have mentioned here are clear, right? If any confusions are there, please tell me. Okay, first take lambda, that is de Broglie's equation. From that we can connect it to the quantization condition from the Bohr's model, that mv equals to nh by 2 pi r, so that wherever I have mv, there I can write this right now, so that you can write in this way and you will get the simplification answer like this. Okay, hope up to here it is clear, right? Let's move forward. Try to get give me your answer for this. It's again easy. The radius of second orbit of lithium plus is x, and the expected radius of beryllium, third orbit of beryllium is, it's again easy comparison of two things only. Yesterday also we did these model questions. If you have attended my previous live session, you can easily answer this. See, what is the radius formula you can use? Radius equals to radius of an nth orbit is equals to 0.529, that constant I am taking it as a naught. Okay, n square by z. So this is the formula you can use. See, radius of second Bohr orbit of lithium is lithium ion, lithium plus 2 is x. So it means R2 of Li plus 2 is equals to a naught into R2 now second Bohr orbit. So here it should be 2 square 4. Lithium, what is the atomic number? Hydrogen, helium, lithium. So 3 you can write. And the next one here expected to be the radius of third orbit of, it means R3 of beryllium plus 3, beryllium plus 3 is equals to a naught into, so n square, here it is second orbit 2 square 4, here third orbit 3 square 9 you can write here, beryllium atomic number is 4. Okay, you can remove these two things. And then next here expected to be, if this is x, if this is x value, now what is the radius of this thing, that R3 is how much they are asking. So you can simply write it as x by R3 of beryllium is equals to, now this is 4 by 3, and here it is, you can write it as in the reverse manner like 4 by 9, that's it. So 16 by 27. Okay, so this is x by R3. So you can write here R3 will be equals to 27 by 16, 27 16 x. So okay, 27 by 16 x. So option C is your perfect answer for the question. Okay, hope the discussion is clear. Guys, if there is any confusion, feel free to mention in the chat box, because anyways I have given every step in the simple way only, right? If there is any confusion, please tell me. If no confusion, let's move forward. Yeah, so tell me what they are saying. The shortest wavelength of hydrogen atom in the Lyman series is lambda. What they are saying? The shortest wavelength of hydrogen in the Lyman series is lambda. The longest wavelength in the Balmer series of helium plus is. Okay, again this is also simple, very simple. Just follow the steps. What they are saying? Shortest wavelength. What is the Rydberg's equation here? It's a like 1 by lambda, which is connecting wavelength to the transitions, like 1 by lambda equals to RH z square 1 by n1 square minus 1 by n2 square. This is what the formula we can use here right now. So they are saying shortest wavelength of hydrogen atom in Lyman series. See, for Lyman series, what is the transition? So n1 should be 1 and n2 can be any number greater than 1. Okay, it can be 2, 3, so on like that up to infinite we can say. Okay, now they are saying the shortest wavelength. Shortest wavelength means, see, if these are the energy levels, if I say these are some energy levels. See, this is energy coordinate now. So now as n value increases, this is 1, this is 2, 3, 4, 5, so on infinity, like that we can move. Okay, so if I say from here to here transition 2 to 1, this is small energy difference, means maximum lambda here, but they are saying shortest wavelength, it means minimum lambda they want, minimum lambda possible from the infinite distance right now. So n2 should be infinite, that's it. Okay, that's it. So this is how you need to fix your n1 and n2 values first. Okay, for the Lyman series first, this is for Lyman series. Okay, and the next one here they are saying longest wavelength, this is shortest wavelength of Lyman series, this is shortest. Okay, the next one is what they are saying, longest for Balmer series. Balmer series, it means Lyman, Balmer no second one, that is n1 should be here 2 and n2 can be anything other than, I mean greater than 2, like it can be 3, 4, 5, so on, like this up to infinite. Okay, now they are saying here longest wavelength. See, longest wavelength for Balmer series means shortest or smallest energy gap. So for Balmer series, shortest energy gap where we have 3 to 2 is the smallest energy gap, that is longest wavelength. Okay, energy and wavelength are inversely proportional, that's why it will become the longest. That's it, we are almost done. Fixing these numbers is important without having any confusions. Okay, first fix these numbers, then try to substitute in the formula. So here I am taking 1 by lambda of hydrogen atom by 1 by lambda of helium atom, helium place. Okay, this is what they have mentioned. Okay, just take the ratios here, that's it. Okay, so here what I can write here, z square like RH is a constant, here also it's a constant, you can write as it is, we can remove them also. Z square, hydrogen atom atomic number is 1, helium atom ion atomic number is 2, square 4. Okay, you can write 4 here. And then next 1 by n1, what is the n1 here? 1 itself. N2 is infinite, so something by infinite means it is 0 here, that's it. Okay, and here what about this 1 by n1 value for Balmer series here we have is 2 square means 4. Okay, and n2 value is 3, square means 9. Okay, you can substitute like this. So you can remove this RH here, right. Then next one here, what I am writing, just see here 1 by hydrogen, lambda of hydrogen by here lambda of helium ion, that's it, wavelength of helium ion. So we got 1 by 4 into this one is how much? This one LCM you are going to get 36 and 9 minus 4 is 5. Okay, so this will be 9 times. Okay, that is what? 9 by 5. What is the answer we are going to get finally? 9 by 5. So finally they are asking lambda of helium ion means what you can write? 9 by 5 times of lambda of hydrogen, that's it. This is your answer for this question. Okay, and you know, yeah, we have answer here 9 by 5 lambda. Yeah, you know, these model questions are most frequently asked in the exam. Most means most, whether it can be NEET, JEE or EAPCET. Especially NEET and JEE, one of the most repeated topic is this one. Okay, right, let's move forward. Tell me for this, if the radius of first Bohr orbit of hydrogen atom is A0, then the de Broglie wavelength of the electron in the third Bohr orbit is how much? Okay, now how can you answer this? Once again try. If the radius of first Bohr orbit of hydrogen atom is A0, it means we are writing now radius Rn equals 0.529 n squared by z we are writing now. So first Bohr orbit of hydrogen atom means this also 1, here it is also 1. So it means R1 of hydrogen will become 0.529. This is equals to A0 they are saying. So wherever you have constant this value you can put it as A0, that's it. Okay, then the de Broglie wavelength of electron in the third Bohr orbit. Okay, third orbit. Okay, so again this is the one which we have did previously. Yeah, I think same question, no? Once check. This is for fourth Bohr orbit. Okay, similar question, not exactly same. This is for third Bohr orbit. Now what we need to do, tell me. See, we got lambda equals to h by mv. Okay, and from Bohr's model what we have here, mvr equals to nh by 2 pi, right? So from this what they are asking, okay, so now here I can write in the place of mv as nh by 2 pi r. Okay, so wherever I have mv, I can replace with this. Okay, I place this one equation in this star equation. Now what happens? Lambda is equals to h by nh, mv place I am writing nh by 2 pi r, that is 2 pi r, that's it. Okay, so h can be removed, so you got n lambda equals to 2 pi r n for an nth orbit. Okay, so this is again one of the important equations for a de Broglie's wave equation. Okay, n lambda equals to 2 pi r n. Okay, so when n indicates the nth or nth orbit here. Okay, so they are saying third orbit 3 lambda equals to 2 pi into a naught into n square by z, n square by z. This is a formula to be used here. Okay, because radius formula what we have, radius is equals to 0.529, that is nothing but a naught into n square by z. So I have written there. So now what you can make here, see this is n, this is square, so remove one time. Okay, and they are asking for hydrogen atom only, lambda equals to 2 pi into a naught, atomic number is 1, asking for third orbit 3. Okay, so it becomes a 6 pi a naught, that's it. This is how you get the final answer. So what is the value here we got? Lambda is equals to 6 pi a naught. We have option number C as your answer for the question. Okay, so I hope, is it 2 pi r, yes, cartoon kids, right, it's correct. In the chat box, yeah, whatever you mentioned, it is correct. Yeah, the next here, yeah, the next question here we have is this one. Just read the question. Assume that the radius of first Bohr orbit of hydrogen atom is 0.6 angstrom. Then the radius of third Bohr orbit of helium ion is, very easy now. So first Bohr orbit of hydrogen atom, generally we will take 0.529, that a naught value that is given here as 0.6 angstroms. Okay, so as per them we will do the question. See, radius of an nth orbit is equals to like some constant into n square by z. Okay, so now for first Bohr orbit they are seeing this much, it means a value here you can say 0.6 into n square is how much, they are saying third means 3 square 9. Okay, and helium means atomic number is 2, that's it. Okay, so this is Rn, so your answer in here it is in angstrom formula, here I have taken. So this will be 0.3, so this is 3 into 9, 27, so 2.7 is the radius of third Bohr orbit of helium ion. Okay, this is in angstroms. Okay, so here helium ion in picometers they are asking, means you just multiply with 100. Okay, so that you will get 270 picometers, that's it. This is your final answer. Okay, right. Okay, if there is any blur, screen is blur, yeah, wait 1 minute, let me connect this. Yeah, I hope it is clear now. If there is any blur, next time please inform me here. Let me put this. Okay. Yeah, so the next question here we have is, look at this, when the excited electron of a hydrogen atom from fifth state drops to the ground state, from where to where? So highest energy level N2 is equals to 5, dropping or falling into the first energy level N1 equals to 1 here, ground state. Okay, the maximum number of emission lines observed or number of emission lines possible here is, so it's very simple. So whenever they are asking for ground state, so you can simply say like you can use this formula directly, summation of, you can use this formula or you can use n into n minus 1 by 2, this formula also, it's simple. Okay, so number of spectral lines is how many here, 5 into 5 minus 1 is 4 by 2, this is 2, so 10 lines we are going to get. So now what are the 10 lines we are going to get? It is also easy. Yeah. Now how can you justify these 10 lines? Just take the lines here. See, this is ground state, n equals to 1, 2, 3, 4, 5. Like this you can take 5 because they are saying from 5th state to 1st state. Like that you take 5 levels, 5 energy levels. So now electron directly can take transition from 5 to 1, or electron can reach 5 to 4, 5 to 2 and 2 to 1, or electron reach 5 to 3 and 3 to 1 directly, or 3 to 2, 2 to 1, already we have written 2 to 1, okay, or electron reach 5 to 4, okay, and 4 to 3 it can reach, or 4 to 2 it can reach, and 2 to 1 already we have written, that's it. Now count the number of lines we got here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So one more line is missing. What is that? Directly from 4 to 1 it can directly fall. Yes, 10 lines we got. So these are the 10 lines we are going to get. Now check number of lines falling in the Lyman series. So number of lines in Lyman series how many? From nth state to ground state now. So 1, 2, 3, 4. So from any higher energy level to ground state, we can say that lines comes in a Lyman series. Now how many lines? 1, 2, 3, 4. So number of Lyman series lines if they ask, what you need to make? Number of Lyman series lines, how many we got? 4 now. So it's very easy. You can use this formula. You can use this formula. n minus 1. See, if they are saying for Lyman series, you can use n minus 1. So n is 5 minus 1. So 4 lines will fall in the Lyman series. Okay. Now if they ask number of lines in Balmer series, see Balmer series how many are there? See 1, 2, 3. Okay. It means n minus 2 you are using. So 5 minus 2, that is 3 lines are in the Balmer series. I hope you got. Now how many lines are in the Paschen series? That is third level. See n minus 3, that is 5 minus 3 here, 2 now. So only 2 lines. See 1, 2. This is how you need to give your final answer. Okay. If they ask for total number of lines, this is the formula. If they ask only like individual number of lines that falls into Lyman series, Balmer series from an nth level, you can use this kind of formula. I hope this discussion is also clear right now. Yes guys, if this is clear, please hit on the like button, or otherwise mention in the chat box. Okay, next let's move forward. Look at this. The question says the kinetic energy of an electron in the second Bohr orbit of a hydrogen atom is equals to h square by x m a naught square. Okay, the value of 10x is. Okay, one of the important question this is, because same model question were repeated in the JEE advanced exam also. Okay, so let's do this. What is the kinetic energy formula? Kinetic energy K I am saying equals to half mv square we have. Okay, and they are asking us to relate this with the second Bohr orbit. Okay, it means Bohr orbit we need to consider. So it means there is mv here. So we have a quantization condition now. mvr equals to nh by 2 pi. So nh by 2 pi. From this we can relate them. See here I have mv square, but here we have only mv. So in the place of mv I need to substitute this nh by 2 pi r. Okay, for nth orbit 2 pi rn. Okay, now what happens, tell me? What happens, tell me here? This one I am writing like multiplying and dividing with m. So now what happens if I multiply and dividing with m? Now what happens? It becomes k is equals to 1 by 2m into mv whole square it becomes. Hope up to here it is clear. See, divided with mass, multiplied with mass to this kinetic equation, kinetic energy equation. So 1 by 2m mv square we got. Okay, mv whole square we got. So now wherever I have mv, I can place it that thing. So kinetic energy is equals to 1 by 2m into mv means nh by 2 pi rn whole square. Okay, yeah, we got this up to here. Then next, you can write this as n square h square by 2 square means 4 pi square r n square. That's it. This is what you can write. Okay, so they are asking us to write in this format. Okay, and here we have 2m also, so it means here you can write 1 by 2m. So 2 4s are 8, so 8m I am writing here. Yeah, that's it. Now which one? Second orbit now. So n square is 2 square, 4 h square, and here 8 pi square m, and Rn, what is the radius of an nth orbit? A0 into n square by z. A0 into n square by z. So now hydrogen atom now, see they are saying for hydrogen Bohr orbit means you can default you can consider hydrogen atom as they given there. Okay, so here n square we have, it means r square rn square, so it means if upon squaring here you need to square here also. So a0 square, okay, a0 square n power 4 z power 2 you can write. Okay, z power 2 you can write. So here it becomes n power 4 z power 2 you can write. That's it. Okay, try to simplify that. What happens here? 4 h square by 8 pi square m. Okay, here a0 square as it is, and n is 2 square, 4 square 16 here, 16. Okay, so like 2 2s are 4, 4 2s are 8, 8 2s are 16. Okay, that's it. And here it will be z square, atomic number is 1. So what is the final answer we got? This is 2 times. So in the denominator 16 2s are 32 pi square into m a0 square, and here it is h square. That's it. Okay, so now compare the final answer with the equation that we have here in the question. See, they are saying h by x m a0 square. So in the place of m a0, like x place, we have this thing right now. Upon comparison, x is equals to 32 pi square. Okay, so just simplify this 32 into 3.14 to the power 2. Okay, so this one upon simplification you are going to get this as 315.5. Okay, and they are asking us to take it as 10x. This is our x value. So 10x means it will be 10x means it should be 3155. So this is your final answer for the question. Okay, so I hope each step are clearly discussed without having any confusion. Right now, if there is any confusion, please mention in the chat box. Once again, please practice this question once again by pausing the video, or after this session, please try to solve this question one more time. Yeah, let's move forward. Yeah, so now tell me again, this one we just know we did the shortest wavelength of hydrogen atom in the Lyman series is lambda 1. Then the longest wavelength of Balmer series. Again, we just know we did, I think so, same model question we did. So just try this and tell me your answer in the comment box for this. Okay, next, what about this question? This is from quantum number related question again. The number of electrons present in all the completely filled subshells having n equals to 4. See, n equals to 4 they are saying, quantum number n equals to 4, number of electrons present in all the completely filled subshell. Now what are the subshells we have here? N 4s subshell we can have, 4p we can have, and d we can have, and f subshell also we can have. Okay, these are the 4 possible subshells we have with 4, n equals to 4. Okay, so now in this we can have one orbital like this. Okay, right now. So completely filled they are saying. So p orbitals are 3. Okay, so p orbitals are 3 means you can say 3 p orbitals like this, and d orbitals are 5, and f orbitals are 7. 7. Okay, so now what they are saying, completely filled. See, in each orbital there will be one half, plus half, and there will be minus half now. So it means each orbital there are 2 spins possible. So out of that they are asking only for 1 plus half spin. It means how many orbitals are there totally? These are 7 plus 3, 10, okay, plus 5, 15 plus 1, 16. So total 16 electrons are there with plus half spin. So this is how you can answer this. Okay, and now for example, for a given n value, total number of electrons possible, if they ask, you just take it as n square, 2n square you can say. Okay, so n square here, 4 square 16 into 2, each orbital can be accommodating 2 electrons now, that is 2 into 16. So total 32 electrons can be accommodated. Out of the 32, 16 are with plus half and 16 are with minus half orientation, spin of electron will be present. Okay, is this clear? Yes, if it is clear, let's move forward. Yeah, now look at this, the 4 quantum numbers for the electron in the outermost orbit of potassium are. So what they are asking? They are asking for 4 quantum numbers for electron in the outermost orbit of potassium. Now what is the atomic number of potassium? It is 19 now. Now tell me, what are the electronic configuration here we have? So like 1s2, 2s2, 2p6, 3s2, 3p6, okay, 3p6, how many over here? Up to here 10, okay, 3s2, 3p6, 18 over. The next 4s2, 3d, 4s2, 3d10 means it's going up, it is only 19, up to here 18 over. So 4s1 we got, okay, up to here it is 18, argon configuration over. What they are asking, the last 4 numbers of electron in the outermost orbital of this potassium. This is the outermost orbital now. So now what is that? N value is 4 and L value for S orbital will be 0, okay, and the next one here is ML value. ML is how much? ML lies from minus L to plus L. So L value 0 means ML also 0. The next spin quantum number will be how much? Spin quantum number, if it is 1 electron, either you can take plus half or minus half. In all option it is plus half only. Yeah, it is plus half. So where do we have such option? L4, N0. Yeah, second option will be your answer for the question. Okay, right. Let's move forward. Yeah, see, similar to the previous question, what they are asking, the maximum number of orbitals which can be, identified with n equals to 4 and ml equals to 0. So here magnetic quantum number should be equals to 0 for the possible orbitals from this n equals to 4. If n equals to 4, we can write 4s, we can write 4p, and I can write 4d and the next 4f. These are the subshells we have. Okay, these are the subshells we have. Once again blur. Let me correct this. Yeah, now it's fine, I think so. Maximum number of orbitals which can be identified with n equals to 4. You can write like this, what are the subshells we have again. So here ms value is how much? See, first of all you need to know for s orbital, remember for s subshell L will be 0, for p subshell L will be 1, for d subshell L can be 2, for f it can be 3, that's it. Okay, up to here it is clear now. So for S, L equals to 0 now, so ML value also 0. For P it is L equals to 1 now, so ML will be minus 1, 0 plus 1. Similarly for D, you tell me now, for D L value is 2, so it can be plus 2, plus 1, 0, minus 1, minus 2. So now ML value is how much we got for this center one? 0. Okay, like that, if you take each of this orbital, each of the subshell, in each subshell there will be one orbital with ML value 0. So total 4 they have seen, 4 subshells are there. In each subshell there is one orbital with ML value 0. Okay, so it means 1, 2, 3, 4. So answer should be here 4. What's your answer here to be taken? 4 should be your answer for the question. Okay, hope this is clear. Is this clear or any confusions are there? No confusions. Okay, right, let's move forward. Now they are asking the orbital angular momentum of an electron in 3s orbital is xh by 2 pi. The value of x here. See now what is the orbital angular momentum? Angular momentum here, orbital angular momentum, just take it, root over L into L plus 1 h by 2 pi. This is what the formula to be used here. Now they are asking for 3s. So for 3s orbital, what is the angular quantum number here? It is 0, no? L value is 0. So if I take here 0 into something, so everything becomes 0, no? So 0 h by 2 pi. So you can write x value as 0 h by 2 pi. So what will be your answer for this? X should be equals to 0. Okay, I hope this discussion is clear. Now I am asking what is the orbital angular momentum for 3p orbital. Please give me your answer in the comment box. You can do it for 3p or even for 3d or even for 4f, like that also. Okay, you just tell me for 3p and 3d like whatever the answers you are getting for them, for the orbital momentum, orbital angular momentum, please give me your answer in the chat box. I will definitely look into it and I will tell you whether it is correct or not based on your understanding. Okay, right, let's move forward. Yeah, this is the last question of this session. Okay, because in the last session also we have covered structure of atom, questions related to NEET especially. Okay, and in this session questions related to JEE, if you have observed, all these questions are from JEE. Okay, that's it. Okay, maximum questions are covered, and if you have any confusion, please let me know in the chat box. We will cover those questions also. Okay, no worries. Now look at this. Which of the following is correct plot for the probability density, that is probability density psi square r as a function of distance r of an electron from the nucleus for 2s orbital. See, first of all via x-axis if you observe, it is r. Okay, so here the graph is for radial distribution. Okay, so now how can you radial probability distribution, I can say probability density, I can say. So first of all you find number of radial nodes that are possible for 2s orbital. So it can be n minus L minus 1 now. So n is 2, L is 0, minus 1. So radial nodes are 1. So how many radial nodes we got? 1. Okay, and if you write the orbital structure like s subshell structure like this, s orbital will be like this. See, if this is a nucleus, around the nucleus only we have lot of electrons right now. So electron density is more at the nucleus, at the center of this s orbital. Okay, it means the graph should start from peak, like from higher state, not from 0. It should be from maxima. Okay, so now with the maxima, radial node should be 1. So what do we mean by radial node? I mean nodes here. See, if you are writing a wave like this, the number of times it is touching like this to this x-axis, this is called node now. So in the graph also, just identify it should touch one time to this x-axis. Okay, one time to this x-axis, and you should ignore the initial point and the last point. Okay, it means in between them. If you observe this fourth graph, there are 2 times it is touching, and s orbital graph must start from the maxima here. Okay, yes, it is starting from maxima, it is also starting from maxima, all graphs are starting from maxima. So let us understand how many nodes are there here. Here there are 2 nodes, but how many we require? Only 1. So how many times it is touching here? Only 1 time. So it means radial nodes are here 1. So perfect answer for the question is 2. Let me give you, this is for 2s orbital. Okay, let us conclude which orbital these graphs are showing. See, there is no, not even one time also it is touched. It means this must be 1s graph. Why 1s? Because radial nodes, if you calculate n minus L minus 1, no? So for 1s, 1 minus 0 minus 1, 0. Radial nodes are 0 for 1s. Okay, now radial nodes for 3s is 3s orbital are how many? So if you calculate for 3s, for 2s we got 1 now. For 3s definitely we will get 2. So it means this graph represent for 3s. Okay, 3s. Okay, and what about this graph? 2s is touching one time. This is also no. Okay, Yeah, see again, sir, this is also touching one time now. So what makes the difference between them? See, they are taken psi square graph. Psi square means if it is psi graph, this will be the correct. But they are saying psi square now. So psi square means, for example, if you say minus 1 whole square is a, what will be the answer? For example, psi is equals to minus 1. Okay. Now psi square means what it should be? Psi square means what it should be? So minus 1 whole square. It means all the time this should be positive only. There should not be any negative values here. See, here you got minus, here plus. It means this will be valid for psi 2a's. This is not for psi square. Okay. But here you got only positive terminal. See here, positive low, like that only. So perfect answer for the question is B. Okay. And I hope you got, this is for psi 2a's graph. This is for psi square 2a's graph. And these are psi square, they are also having positive for respect to atomic orbitals. Okay. Hope complete discussion of these graphs is clear. If there is any confusion, please tell me. No confusions, right? Right. So this is about the session. If you have any confusion, please let me know in the chat box. Yeah, if no confusions, let's close the session. Yeah, that's it. Yeah, thanks for watching. Stay connected with this NEET World YouTube channel, and whenever you have doubts, please write in the chat box. We will definitely discuss them. And if you like the content, please share with your friends who are preparing for NEET, JEE and EAPCET exams. Thanks.